Okay, I'm trying out a new document camera here, so hopefully the sound and video quality will be better. We'll see. But I'm going to use this to record the answers to the homework problems from Chapter 3 on forces. Let's go ahead and start off with homework problem 1. Here we're looking for the acceleration in feet per second squared of a 275-pound refrigerator riding on a dolly subjected to a 75-pound force. And we're neglecting the friction in the dolly wheels and rounding our final answer to 1 decimal place. So first we want to kind of get a picture of what's going on here. We're looking for an acceleration, so that's an unknown. But we do know the weight of the refrigerator, that's the 275 pounds, and it's riding on a dolly subjected to a 75-pound force. Okay, so my force here is going to be 75 pounds, and my weight is 275 pounds. Now remember that weight and force are very similar, right? They are both mass times an acceleration, but weight is your mass times your gravitational acceleration, and force is a mass times whatever acceleration is happening as a result of that force. So in order to solve a problem like this, and we can picture what's happening here, the dolly and the refrigerator are at rest, and then all of a sudden it's being pushed. I want to know what its acceleration is. So in order to solve this problem, we're going to have to solve it just like we did the other problems in this chapter that we're talking about on Tuesday. We're going to take 2 steps here. We're going to find the mass first, because we've got 2 equations we're going to want to use when we're looking at problems like this on this Newton's second law page. We know that F equals ma and that W equals m times g. So I'm going to go ahead and put those up in the corner here, that F equals ma and W equals m times g. In this equation, we're looking for this a. We don't know it, and we also don't know the mass, but we do know the force applied. And we know the weight, and we always know that acceleration due to gravity, and we don't know this mass. So when we take a look at these equations, the first thing that we can solve for is this mass. We can't solve for the acceleration yet because this equation has 2 unknowns. But this equation only has 1 unknown, so we'll start there. So we'll find the mass using this equation. So we have W equals mg. But we want to solve for mass, so we're going to get that by itself on this side of the equation, and we can do that by dividing each side by g. Here the g's will cancel out, and we wind up with W over g is equal to m. Okay, and when we plug our numbers into that equation, we'll put our weight is 275 pounds over that 32.2 feet per second squared gravitational constant. And when we do that math, we wind up with, I'm going to go out to 2 decimal places for mass here, 8.54 slugs. All right, so that's the mass of that refrigerator. Now I want to figure out what the acceleration is. So I'm going to use my other equation. Now I've figured out mass, so now I know 2 things in this equation, and I can solve it for acceleration. So that's my second step, is to find my acceleration. I'll use my F equals ma equation. I want to solve for a, so I'm going to divide both sides by m. I wind up that force over mass equals acceleration, and when I plug the numbers in, I get, remember it's a 75-pound force, and it's 8.54 slug mass. And once I do that, I'll wind up, and I just want it to 1 decimal place, I'll wind up with 8.8 feet per second squared. Okay, so that's how to approach these types of problems when you're given some kind of weight and force, but looking for an acceleration. You've got your 2 equations here. Figure out what you know and what you don't know. Solve for the mass, in this case, first, and then plug that into the second equation. Okay, that's the end for homework problem 1. I'll be back in a little bit, and we'll go over homework problem 2.